Let's talk about finding the end-of-line resistor in the field. How to prove circuit supervision in minutes. Don't guess where it is, prove where it is. The problem is most technicians assume the end-of-line resistor is at the end, but in the field it gets moved. It gets left in the panel, it gets installed mid-circuit. Assumptions is bad troubleshooting. The goal, you are not looking for the resistor, you are proving where the circuit actually ends, whether supervision is real, whether the panel can see the whole circuit. The 5-step process: make it safe, isolate the circuit, measure resistance, prove the end, verify the true end. Step 1, make it safe. Before measuring resistance, remove power when required. Remove both field wires from the panel. Never measure resistance on a live circuit. Why this matters: your meter injects voltage in ohms mode. If still connected, you get false readings, you can backfeed the panel, you can damage equipment. Step 2, isolate the circuit. At the panel, remove both conductors from the panel. Now you are measuring field wiring only, not the panel. Field tip: experienced technicians may sometimes isolate only one conductor for quick checks, depending on circuit type and conditions. Step 3, measure resistance. Measure across the field wires. Expected result: approximate end-of-line resistor value. Examples: 4.7, 10, or 47 k ohms. What the reading means: correct resistance, end of line is somewhere in the field. OL or infinite, open circuit, or missing resistor. Low resistance, short or wiring fault. Horn strobe circuits may not read like a simple resistor circuit. Appliances can affect resistance readings. This is the key. This step does not prove where the resistor is. It only proves that it exists somewhere. Step 4, prove the end. Go to the last device, remove the EOL resistor. Now measure again from the panel. But remember, notification circuits may still show device resistance. The expected result: with the EOL removed, the original end-of-line value should change or disappear. You may read OL, device resistance, a different resistance value, different readings by polarity. If the reading still looks supervised, stop and investigate. Possible causes: another end-of-line resistor is still connected. Multiple resistors are on the circuit. The circuit branches before the last device. NAC circuits are different. On horn strobe circuits, don't expect a perfect open. Appliances can affect resistance readings. The test is not, do I read OL? The test is, did the end-of-line value disappear? What that means: if the EOL is not at the end, the panel cannot see broken wire past that point, missing devices, partial circuit failures. System can look normal and still be wrong. A real-world example: system shows normal, but the end-of-line resistor is installed mid-circuit. A break occurs past that point. Panel still sees correct resistance, no trouble, hidden failure, hidden loss of supervision. Step 5, trust the meter. Don't trust the drawings, labels, or that's how we always do it. Trust measured resistance. Common field mistakes: end of line left in the panel, end of line installed in the first device, multiple resistors on circuit, wrong resistor value. Troubleshooting mindset. You are not chasing devices, you are verifying electrical conditions. The panel reacts to physics, not guesses. Meter rule. Ohms is power off, always. No exceptions. Finding the EOL is not visual, it is electrical. Measure, verify, prove. If you don't prove it, you don't know it. Don't guess where it is, prove where it is. The meter reports what the circuit is doing. Your job is to understand why.